Hey guys, hope you're having a great Tuesday so far. As I looked at math from yesterday, looks like you guys are doing really well. Hopefully the video was helpful and allowed you to understand what we were doing as far as finding area of parallelograms. We're going to continue on with that today, and this lesson might go pretty quickly. I'm not going to tease you with different things and make you figure things out. I'm just going to lay it out for you because triangles can be a little bit tricky sometimes as far as understanding why we do it the way we do. So yesterday we looked at area of parallelograms and rectangles, and we used the formula area equals base times height. And when we do that, we're able to figure out what the area of the rectangular parallelogram is. So in this case here on this rectangle on screen, you know, our base is 4 and our height is 2, so 4 times 2 is 8. You can see the 8 squares there. And so it's a pretty simple concept to get and understand. So thinking about parallelograms and rectangles and the formula we use for finding area, how do you think that would change when it comes to finding the area of a triangle? I want you to pause the video, think about it, think about that formula. Could it be useful or used to find the area of a triangle? Okay, so as you're looking at this triangle here, you're probably noticing, yeah, the base is very clear, easy to see. There is a base. So as far as what could be useful in that formula, the base is definitely there, but just like a parallelogram, triangle has these slanted sides. And these slanted sides aren't necessarily a length we would use to represent the true height of the triangle. So how do I figure that height out? Well, in the case of a congruent triangle, which is what this is, and a congruent triangle is when all of the sides are the same. In the case of a congruent triangle, it's really simple to figure out the height of the triangle. You're basically going to come to the point of the triangle, the tallest point of it, and you're going to go straight down and count up the units there. So let's go ahead and do that with this triangle, and we'll figure out what the base and the height is, and then we'll move on to the next part and figure out how we can find the area. Okay, so let's count the base up here. We can see that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 units here make up the base. And then, like I said, if we come up here and just go straight from that highest point, we can see that there's 1, 2, 3, 4, 5, 6, 7, 8. And so my height would be 8 on this triangle, okay? So the formula that we've used for parallelograms and rectangles would tell us to take the base and the height and multiply them together, and that should give us the area. So if I've got a base of 9 and a height of 8, well, 9 times 8 is 72. But look real close at this triangle. Pause the video and just kind of do a quick count of those squares. Does it look like there's 72 squares in that triangle? So there's clearly not 72 units here in this triangle. So obviously I can't use this formula to figure this out. There's got to be something else that has to be done to figure it out because it's nowhere near 72. So let's take a look at this triangle and take you into the last part of this formula of what I need to do and why. Okay, so here is our triangle again. I've changed it up just a little bit. Watch what I'm going to do with this triangle. I'm going to take this triangle and I'm going to create another triangle that's the same size of it. Okay, I'm going to take this triangle and then I'm going to turn it over. And then from this point, I'm going to take those two and put them together. And look at what shape I've just created. It's a parallelogram, Mr. Jensen. Yeah, I've got a parallelogram. When we think about triangles, triangles are essentially half of a rectangle or a parallelogram. And we can decompose triangles to create rectangles and parallelograms. If we take a look at an example like here, here's the same triangle, decomposing it by cutting it in half right here along the top, and then taking that half and flipping it and setting it down next to the rest of the triangle, I've now composed a parallelogram. And so I've taken this triangle and I've created something that we're very familiar working with in area from yesterday's lesson. Okay. There's also this way as well. You can take that same triangle, cut it in half, cut that top part into 2 triangle wedges, and then strategically place both wedges on the end of the base of that triangle, and now you've got a rectangle. And so, as you can see, we take this triangle and we decompose it into a parallelogram or a rectangle. So I'm going to come back to this example here that we started with, where I had the triangle, and then I created a second triangle that was the same way, flipped it over, and connected it to create the parallelogram. I'm going to use this example because it's going to represent the formula that we want to use to find the area of triangles and help me to explain it. So if we take a look at this triangle that we started with, we had that base of 9 and the height of 8. And so we did our 9 times 8, right? But we know that that gave us too much, gave us 72. So the last part of the formula for a triangle is, once we've figured out our base and our height, what we're going to do next is we're actually going to divide. And so we're going to take the base and the height, multiply it, and then we're going to divide it by 2. I want you to pause the video and think about it for just a minute. Why would I want to divide the base and the height by 2? Think about it, formulate an answer, and then unpause the video and we'll talk about it. Okay, hopefully you've had a chance to think about it. Now let's go over it. So the formula for the area of a parallelogram can be used, that's our base and our height right here, and then divided by 2, as the area of one triangle is half of the total area calculated. So when you do the 9 times 8, you get 72. But this is the formula for a parallelogram, which is what we see right here, isn't it? This whole thing here with both the triangles is a parallelogram. So 9 times 8 is 72. Yes, there are 72 whole squares here. But because I had to create that second triangle to make the parallelogram, I need to now divide by 2 or by half, because in reality, the triangle that I started with is only half the total of the area found using the parallelogram formula of base times height. So the reason I divide it by 2 is because what we see in the picture here, it takes 2 triangles to make the parallelogram. But in order to get the area of the one triangle I'm actually looking for, I then need to divide half of the area that I found out so that I can find the area for the triangle that I have. So now I would take 72 and I would divide that by 2, and I would figure out what half of 72 is. So go ahead, do some mental math and figure out what is half of 72. Hopefully you were able to come up with an answer of 36. Okay, and if you look at this again now, it's very clear that there should be 36. When you count up the whole squares individually and then you start to put the fractional amounts together, 36 makes a whole lot more sense than 72 did. So I hope you understand why I want to do that as the formula for the triangle. So here it is written out using the formula. So area of a triangle. So if I want to find the area of a triangle, it is area equals base times the height, and then we're going to divide that by 2, or basically we're going to cut it in half. Okay. So that's the formula right there. That is what you want to use today on your assignment. Okay. Now some triangles are easier than others to figure out the height. On a triangle like this, where all the sides are the same, you can come right to that top of the tip of the triangle and go straight down and figure out the height. But as we know with geometry, not all triangles are created equal, and there are many different shapes that triangles can be made into. So how do we find the height when the triangle isn't exactly perfect like this one? Well, let's take a look at an example and we'll figure it out together. Okay, so here's an example of a triangle that isn't exactly straight up and down 90-degree angles like other triangles that you might see. We can see that we have a clear base here. We can figure the base out no problem, but then we've got this side which does nothing to help us find the height. We've got this which is also slanted. So when we run into triangles like this and we've got the grid here, it's real simple to find the height. We're going to do exactly what we did with parallelograms. When we wanted to straighten those back out and make them look more like rectangles, we kind of created that invisible section that gave us the height. And so if I do that here with this triangle, and we come over to the tip here that's perpendicular from the base, I can draw straight down my little imaginary dotted lines here that create the piece that would allow this to find the height. Okay, so I've got this right here now. I can now figure out what the height of this triangle actually is because in a way I've decomposed it. I could take this triangle and cut it in the same spot right here and flip that over and it would become this piece right here. If I were to cut, oops, sorry, it's not very straight. If I were to cut right here, I could take this wedge right here, flip it, reflect it, and it would fill in right here and give me that height. So on a triangle like this, now I can figure out what the base and the height are. So just like with parallelograms, I don't want to count any of these dotted lines on the base part because I've already have the base right here. So to figure this one out, it would be 1, 2, 3, 4, 5, 6 is my base. And then over here on my height, I can go straight up now, and it's 1, 2, 3, 4, and 5. So now if I want to do that formula for a triangle, I know that its area equals base times height, so that's going to be 6 times 5, and then I'm going to divide that by 2, or half. So we would go ahead and figure out 6 times 5, and we all know that that is 30. And then I would go ahead and take 30 and divide that in half, and we know that 30 divided by 2 is 15. So I know that this would be 15 square units would be how I'd want to write that out. 15 square units is what this would be. And when we come back and look at it, we can pretty much see there's 15. There's 1, 2, 3, 4, 5, 6, about 7. There's 7 whole ones. And then we have these ones, you know, this piece and this piece would make 8. And we'd have this and this makes 9. And we'd have this and this makes 10, and as you counted, you know, we'd have 11, and then 12, and 13, and 14, and the tip there. So we can tell that it is 15 square units when we do that. We can go back and we can pretty much see it now, okay? So when we've got a triangle like this that's has 2 slanted here, basically go find the tip and go straight down on the grid until you get to the base and then come over. And this imaginary piece is what would happen if I decompose this triangle. Now, if I take a look at this triangle again, let me go ahead and erase everything on here. So we talked about this idea that a triangle is half of a rectangle. It's half of a parallelogram. So on this example, I wanted to take this triangle here and basically reflect it over to show you that if I take this same triangle and create a second one and lay it right on top, opposite of it and reflect it, you can see that it does create a parallelogram. And so again, that's why when we use that formula of base times height divided by 2, that is why I've got to divide that 2 out of it. And sometimes that's a mistake kids make with the triangle formula, is you find your base and your height and you multiply and then you stop. Make sure when you're working with triangles that you do the base and the height and then divide half of that total out. Because as you can see here, a triangle is only half of a parallelogram. So I can't just do base times height and call it good. Make sure you're dividing the 2, taking that half out so that you get rid of all of this that you created to find your height. Okay, so I hope that makes sense. If it doesn't, shoot me a message. We can talk about it more, okay? Let's move on to another example. Okay, so here's another triangle that we can work with and try and figure out what its area is. Obviously, it's not going to be much area. There's not very many squares here, but we want to use our formula and figure this out. But in order to do that, we got to figure out what our base and our height is, and then be able to cut that in half by dividing it by 2. So as I look at this, the base is pretty simple. It's down here along the bottom. It's 1, 2, 3, 4, 5, 6 units here is the base. Now to find the height. I obviously can't use that because it's not perpendicular to my base, and I can't use that because it's not perpendicular to my base either. I don't have any right angles, any 90-degree angles, so I can't consider either of those my height. But I can do one of two things. I can either come up to the tip here, because from the tip here, I can go straight down and create a right angle. I know I'm perpendicular to my base because I have a right angle here and a right angle here. And so I could count up these units and get that, which would be 3. Or I could come to the outside and kind of do that idea of decomposing. See where I just cut it right here? If I were to give you a dotted line here and go out from the tip to the other tip here and line it up, you can see that this piece here, if I were to cut it and reflect it over, it would be the same size. And then again, I've got my rectangle, my parallelogram built in. And so either way, I could use this one, or I could build an imaginary rectangle to the outside of it and figure out the height as well. And as you can see, it's 1, 2, 3 units here as well. So either way you would want to do that would work. So if you wanted to go right inside the triangle and go from the tip down, I'm going to get a right angle. If you want to come from the tip and build out and do your imaginary rectangle, you obviously have a right angle right here. And so you would be able to figure out that the height is 3. So now it would be a matter of doing the formula. So I've got 6 times 3, and then I'm going to divide that in half. So 6 times 3, you guys all know this. I wish you guys could yell it at me. 18, it's 18. And then we're going to go ahead and cut that in half. And 18 cut in half divided by 2 is 9. So the area of this would be 9 units squared. So, and you can see it there. There's less than 10 squares here for sure. There's definitely 9 squares there. So you can see how the formula works again. It really just comes down to if you can find the height, it's the same formula as the parallelogram. You just have to divide things in half, okay? Let's take a look at another one. Okay, here's an example that is oftentimes presented, and they do it to try and confuse you basically. Because what they've done here is you have a triangle where all the sides are the same, and they've gone ahead and labeled 2 of the sides here so that you can see that the triangle is congruent and that all the sides are the same. So you've got your base down here, which is 3 yards. Great, we're going to use the base. But then you notice they also labeled this side of it. And because it's a congruent triangle, it's also 3 yards. But you've got to make sure when they do this to you that you do not fall for this trap. Okay, do not use this as your height. No, no, that is not your height. That is merely a measurement of this side length, okay? As you can see, inside they've gone ahead and cut the triangle. And they've shown you that it is 2.6 yards. This is the measurement that I want to use when I build my formula. So in this case for this one, it would be 3 times 2.6, and then we're going to divide that in half by 2. So I want you to take a minute. I want you to solve this one, pause the video, and then come on back and see if you got it right. Okay, so hopefully you did 3 times 2.6, which would have given you 7.8. And then 7.8 cut in half is 3.9. So the area of this triangle is 3.9 units, square units. Okay, good. Let's take a look at another one. Okay, here is a story problem I want you guys to try, so you'll need to pause the video when you read it and figure it out. But it says each triangle-shaped flag on the bunting has a base of 3 inches and a height of 6 inches. how many square inches of fabric were used for each flag? So I'd like you to go ahead and pause the video. Please write down the formula for this and tell me how much material is used for each one of these little flags on the bunting. Okay, hopefully you took your base of 3 and multiplied it by your height of 6. That should have given you 18. And then you take that 18 and divide it in half, divide it by 2, which would give you 9. So it would be 9. Whoops, didn't want to do that. Let me go back to my draw tool. It would be 9 inches squared is how much each one uses. So hopefully you got that right. Let's take a look at another example. Okay, so let's read through this one and then have you pause the video and figure it out. It says, fossilized shark teeth are commonly found on the beaches of Florida and Georgia. Colette found 2 megalodon shark teeth and wants to use the one with an area closest to 1 square inch to make into a necklace. Use the estimated measurements to determine which tooth she should choose. So you have these 2 teeth here. They've given you a base and a height for each one. I'd like you to figure out which one she should use. This one is, we'll call it the orange tooth, since they're using orange for its base and height. And we'll call this one the pink tooth, since it's got pink color here. So pause the video, take a minute, figure out which one of these teeth is closest to 1 square inch, and then we'll check your answer in just a second. Okay, so on the orange tooth, you should have done 1.6 times 1.5 divided by 2. So 1.6 times 1.5 is 2.4, and 2.4 cut in half is 1.2. On the pink, you should have done 1.25 times 1.7 divided by 2. 1.25 times 1.7 is 2.125. I then divide that by 2 and cut it in half and get 1.0625. So which one is closer to 1 square inch? Well, that would be the pink, as 1.0625 is closer to 1 than 1.2. So pink would be the way to go for that necklace. Okay, our last example here that we're going to look at, and then I'll let you go for the day and you can start your homework, is which triangle has a greater area? Or do they have the same area? Explain your reasoning. So I have 2 very different triangles here, the red and the blue. The red is obviously got congruent sides, whereas the blue does not have congruent sides. They're different lengths and they are slanted differently as well. I want you to pause the video and I want you to figure out the area for both of these triangles and explain. Do they have the same area or are they different? So take a minute and figure that out. Okay, hopefully you figured out that the area of these triangles is the same, even though they look different, okay? Both triangles have the same area. The amount of area inside each triangle is unchanged, even though the vertex, this part of the triangle, the highest point, even though the vertex of the triangle has been moved to the right. So on this one, it's in the center, and on this one, the vertex is on the right side of the triangle. Even though the vertex has been moved, both triangles have the same base and the same height. And if they have the same base and the same height, that means they're going to have the same area. So the base here is 6. The height is 4. 6 times 4 is 24. Divided by 2 is 12. The base here is 3, 4, 5, 6. The height from this point, you could come straight down, is 1, 2, 3, 4. 6 times 4 is 24. Divided by 2 is 12. So even though they look different, they have the same area. Okay, so here is your independent practice today, guys. You need to do both sides, independent and school home, just like yesterday. So question 1 wants you to explain how the area of a triangle is related to the area of a parallelogram. I explained that in the beginning of the video when I gave you the formula. So if you want to go back and re-listen to that, the answer's there on the video. Number 2 wants you to write the formula used to calculate the area of a triangle. I wrote that at the beginning of the video as well. And then on 3, 4, 5, and 6, it wants you to find the area of the triangles. If necessary, draw a dotted line to represent the height and calculate the area. If you don't need to draw the dotted line because the triangle is perpendicular somewhere, don't do it. Just do the base times height and divide it in half, okay? So that is the independent practice. On the school home connection side, it gives you what? 1, 2, I like how it goes, here's 1, here's 2, and then 5 and 6. 3 and 4 don't even exist anymore. We're gonna go 1, 2, 5, 6. Great. So you're gonna do the same thing. You're gonna locate the base, or you're gonna label the base and the height. So on these pictures, label the base, put the number there, draw the dotted line for the height, write its value there. And then use the formula on the open line here and solve for the area of these triangles, okay? So hopefully this video has explained to you why we use this formula, why it works the way it does. If you have questions about this, feel free to reach out to me on Seesaw or Class Dojo, depending on which one you've got open. Kids, you should be on Seesaw. It's going to be your parents that are on Class Dojo. So if you've got questions, let me know. Otherwise, good luck getting this done. It is due on Wednesday, so make sure it's turned in by Wednesday morning because that's when I'm going to start grading them. Other than that, I hope you guys are doing well still. Got some interesting news that I'll probably pass on to you tomorrow, so stay tuned. Hopefully you're all doing well, quarantined in your homes, and you guys aren't going too crazy. But I miss you guys. Hopefully we'll be able to see you soon and talk to you soon. Hopefully we'll do one of these Zoom videos live as well, and you guys can all see each other and talk to each other. Maybe we'll try and do that before the week is over. So have a great day, guys, and good luck. We'll talk to you tomorrow.